Hello everyone. So this is the new unit called as your sequential logic circuits under the course called as your digital principle in system design. So in this unit, so far in the unit number 2, we have discussed about the combinational logic circuit. This unit is completely going to lead with your sequential logic circuits. First, before going into the sequential logic circuits, we need to know what is the difference between the gates and as well as the flip-flops, wherein gates we have used in the previous unit and as well as in the first unit, and what is called as a flip-flop, and what are the two different types of circuits. One is called as your combinational circuit and next one is called as your sequential logic circuits. First, what is a gate is these gates are the building blocks of the logic circuits. Their primary function is to perform decision making operations. Say for example, if we are having an inverter, if the input is 0, then the output is equal to 1. If the input is 1, then the output is equal to 0. Say for example, your IC7408, it's an AND gate. When the two inputs are 1, then the output is a multiplication of the two bits whose value is equal to 1. But whereas let me take an IC called as your IC7432, which is for your OR gate. In this when the two inputs A and B are your 1 and 0, both will get added. 1 plus 0 is your 1, that will be published at the output. And what is called as a flip-flop is, see in this, the gates are not having any memory operations or it cannot store anything, but whereas the flip-flops are the building blocks of the digital circuits. Their primary function, okay, is to store the binary bits, but whereas the primary function of the gate is to give the arithmetic operations and logical operations on the inputs. So I've already told that there are two different types of circuits. One is called as your combination logic circuits and next one is called as your sequential logic circuits. And what is a combinational and sequential logic circuits is, say for example, combinational logic circuits will be having the basic gates and as well as their ICs, and as well as after that we have derived few universal gates and universal ICs, and then some extra other gates is also there. The basic gates are inverters, AND gate and as well as OR gate. The universal gates are your NAND gate and NOR gate, and your other gates are your XOR gate and XNOR gate. So these are called as building blocks. The suggested and as well as these basic gates are the building blocks of the combination circuit. As of your sequential logic circuits is about flip-flops or the building blocks. Say for example, as a flip-flop is about, we are having we'll be dealing with the four different types of flip-flops. One is called as your set reset flip-flop. It's commonly called as your SR flip-flop or RS flip-flop. And the next type is called as your D flip-flop, which is called as your data flip-flop. And the very next type is called as your JK flip-flop. And the final type is called as your T flip-flop. Okay. So where T is called as your toggle flip-flop and D is called as your data flip-flop. Okay. So in which your R and S flip-flop, why the name R and S is means, so R and S are the two inputs, and as of your J and K is about, so J and K are the two inputs, Q and Q bar are your outputs. So when we go into the flip-flops, what happens with the flip-flops and what is the specialty of the sequential logic circuit is, see for example, your flip-flops output logic is here. Okay, so this is your next state logic and this is your memory elements and this is your output logic. This is your external output. See for example, you will be getting your external inputs here and output. Okay, from the output line will be coming to the input. From the output a feedback will be coming from your output and will be fed into the input. So when the next state logic is given to the memory elements, there will be an excitation. So for the memory elements you will be having a clock signal. See, the devices of the sequential logic circuits are of two types. One is called as your edge trigger device and next one is called as your level trigger device. As of edge triggering is about, edge triggering means it can be a clock driven circuits, can be a positive edge triggered elements or else a negative edge triggered flip-flops. And as of level triggering above, level triggering is about, it's called as your enable. Okay, low level enable or else high level. These are the two levels as of your enable type is about. So the flip-flops basic circuit is given here and the block diagram of sequential circuit is this. Basically we'll be having a next state logic because of the input, and there will be some operations inside the flip-flops. Based on that operation, the next output is generated. That is called as your next state logic. That will be having a storage inside, so only memory elements are present to store the operations whatsoever had happened, and that will be pushed to the output. And this is for your external output, which is for the user interface. But before it is pushed to the output, and feedback from the output is given to the input, in order to streamline the output and to make it in a proper way. A feedback is present in the sequential circuit, but whereas as of combinational circuit is about, there is no such feedbacks. See, combination logic. Here, in combination logic, we have studied a few circuits: adders, subtractors, multiplexers, demultiplexers, encoders, decoders, and your magnitude comparators. In all the circuits, the output depends only on the current input, okay, and it's able to perform useful operations like addition, subtraction, multiplication, all the arithmetic operation, and there are some logical operation also. Magnitude comparison means it's a logical operation. Two-bit numbers are there means we can compare which number is the greater number, okay. And next one is called as your it requires cascading of many structures. So if your functionality is more, we need a cascading of gates to get the desired functionality to happen. And as of cost is about, this is costly and it's an inflexible type. And as of sequential logic is about, here the output not only depends on the current input but also on the past input values also. They store information between the operations. There is no need of cascading. Needs some type of memory to remember the past values. So I have told that, as we have discussed, um, before it is moving to the user interface, some part of the output, okay, the current state output and the next state output, everything will get stored in the memory element for some process. So need some type of memory to remember the past input values. And now we are into the differentiation between the combinational circuit and as well as the sequential circuit. So the combinational circuit output is a function of input only, but here output is a function of the present state and the input. And here combinational circuit no memory is there, but whereas in as of sequential is about memory required to store the state. And combinational circuit the output response will be faster, but whereas in sequential circuit output response is slower, because in a combinational circuit you are having a feedback from the output to input, and the output at a state depends on the current input and the previous output, so only a delay is incurred, so it's slower and it's easy to design. And here it's harder to design. As of sequential circuit is about when we deal with the flip-flops, latches and everything. So as of flip-flops is about we need clock signals. As of latches is about we need enable signals. These flip-flops are called as your edge triggered device, and as of latches is about, it's called as your level triggered device, okay. Level triggering means high level and low level, and edge triggering means it can be a positive edge triggered or a negative edge triggered. So the to take up the final decision or final output, it needs time, so it is slower. And as of combination circuit is about, there is no feedback from the output to input, but whereas as of sequential circuit is about feedback is possible. Example of combination circuits, we have decoders, multiplexers, comparators, and sequential circuits, flip-flops, registers and counters. These are the few things that we are about to study. Thanks for listening. Thank you very much.